What are haptic feedback motors? Imagine feeling a tap or a buzz right in your hand whenever you press a button or touch a screen. That sensation comes from something called haptic feedback motors. These tiny devices turn electrical signals into vibrations you can feel, making digital interactions more real. Haptic feedback motors are used in many electronic gadgets to give physical responses. They are a type of actuator, which is a part that moves or produces force in a system. These motors are especially important in electronics and embedded systems because they help users know their actions registered. Sensors and actuators work together here, with sensors detecting your touch and the motors providing the tactile feedback. The most common type of haptic feedback motor is called an eccentric rotating mass motor. It has a small and balanced weight attached to a spinning shaft. When electricity flows through it, the motor spins and the off-center weight causes vibrations. These are simple, cheap, and found in many smartphones and game controllers. But they are a bit slow, taking about 50 to 100 milliseconds to start vibrating. Another type is called a linear resonant actuator. Instead of spinning, it moves a small mass back and forth along a straight line. This movement is driven by an alternating current at a specific frequency. Because of this, LRAS can respond faster and give more precise vibrations. They are used in devices that need more detailed tactile feedback, like high-end smartphones or virtual reality controllers. Piezoelectric actuators are a third kind. They use special materials that change shape when voltage is applied. These can produce very accurate vibrations with low noise. Piezo actuators need higher voltages but are small and can generate complex tactile sensations. They are often used in medical devices or advanced haptic systems. These motors work with a drive circuit that takes signals from a microcontroller or processor. The circuit controls how strong the vibrations are and how they change over time. It does this by adjusting the electrical input, which then creates magnetic fields in the motor. These magnetic fields push or pull the motor's internal parts, causing vibrations. Haptic feedback motors are found in many places. Touchscreens and buttons in phones or tablets use them to confirm your taps. Car dashboards and steering wheels use vibrations to warn you about hazards. Gaming controllers and virtual reality headsets use haptic motors to simulate textures or impacts, making the experience more immersive. Medical training devices also use them to give realistic feedback during practice. When designing systems with haptic feedback motors, engineers choose the type based on how fast they need the vibrations and how precise they should be. They also consider power consumption and size. Control algorithms help by adjusting the motor's vibrations based on sensor inputs, so the feedback feels natural and timely. In short, haptic feedback motors are small but powerful parts that turn electrical signals into touch sensations. They make digital devices feel more real and help users interact more intuitively. Whether it's a gentle buzz or a sharp tap, these motors bring a new level of interaction to modern electronics.